A couple of years ago, Comet 67P held the world's attention as humanity landed its first tiny robot on its face. We cheered, we hugged, we tweeted, but then what happened? Howdy DNews friends and relatives, Trace here. Back in November 2014, Comet 67P churyumov-Gerasimenko got its first man-made visitor in the form of a washing machine-sized lander named Philae. It was supposed to live for a month, but it landed badly, bouncing on the surface and into a shady crater. Without sunlight, Philae only had 57 hours until the battery died. In that time, the scientists gathered reams of data which they have been analyzing over the last year. So what have we learned? Well, firstly, even though it was unplanned, scientists learned something just from analyzing the sound of Philae's bounce. Comets are much harder than previously thought. Comet 67P is probably made of rock-solid ice beneath a 4 to 8 inch layer of dust. We thought comets were soft, and obviously we were wrong. Once it landed, Philae famously discovered organic molecules like acetone, propionaldehyde, methyl isocyanate, and formaldehyde. They don't sound great, but formaldehyde is implicated in the creation of ribose, which is found in DNA. This means if a comet crashed into a planet with the right conditions, like water and warmth, these molecules might help life along, maybe. A major goal of the Philae Rosetta mission was to find water on this comet, and find it they did. Unfortunately, a paper in Science stated the Rosetta's spectrometer for ion and neutral analysis found the molecular makeup of 67P's water wasn't quite right. Here's why. All water molecules are 2 hydrogen and an oxygen, H2O. Here on Earth, all water has 3 heavy water molecules for every 10,000 regular water molecules. Heavy water is also called deuterium, and it simply has an extra neutron in its nucleus. This is completely normal, by the way. The water on 67P, however, it has 3 times the deuterium of our water. This means the comet's water is not compatible with ours. And since these ratios don't really change, this shows comets probably didn't bring water to Earth. Wah wah. That same instrument also made the most surprising discovery on 67P a few months later, molecular oxygen. Published in Nature, the discovery of oxygen was completely unexpected. Astronomers have detected oxygen only twice outside of our solar system, never on a comet. Some scientists felt the presence of both oxygen and hydrogen, combined with ultraviolet radiation from the sun, could cause these atoms to recombine into H2O and O3, water and ozone. But unfortunately, that didn't happen either. As a comet approaches the sun, it warms and develops a tail. The tail spews about 100 kilograms per second in comet material, and that would mean, there would be H2O and O2 everywhere, right? But unfortunately, the ratio of H2O and O2 stayed the same, showing oxygen permeated all of 67P and wasn't combining to make water and ozone. Dang it. But it does indicate that comets might predate our solar system altogether. And remember, 67P is just one comet, and studying which features come from the formation of the universe and which came later is one of the many puzzles, aside from the presence of water, hydrogen, oxygen, and all these other molecules. Maybe once we go to another comet with even more robots or even people, we could learn even more. Look, if you have no idea how we even got to this comet, the thing with Rosetta or Philae or whatever, 1, I'm proud of you for sticking around, hello, thank you. But 2, I did a video on that, so you can check it out here. The flinging of a craft around a massive celestial body at just the right angle speeds up the craft by stealing a bit of energy from the planet. That's kind of mind-blowing, right? Landing on a comet and then an asteroid and then to the moon, to Mars. We're gonna go to Mars, right? What do you think? Where should we go next? Let us know down in the comments. Make sure you subscribe for more DNews. See you later.